Either way, you're going to arrive at your answer. Okay? All right, next, let's look at B. B says y squared times y to the fourth times y third. Okay, so again, check your base. You're multiplying you have a product of three different variables that are powers that all have the same base. So we're just going to use the product of powers property, and we're going to say y is the base raised to the 2 plus 4 plus 3. And again, if that doesn't make sense, go back to the letter A and you can see that all we're doing is expanding that in expanded property, or in the expanded notation, you would have y times y, and then times 4 more y's times 3 more y's. So you can see that you're literally just adding those. So you have y to the 2 plus 4 plus 3 equals y to the 9th power, and that's your answer. Okay? We'll go ahead and work through the next one says x cubed times x. Okay, so in this case, again, you're going to check your base, but you may look at this one and say, but that's not a power. But of course, you can remember that you always have an understood exponent, no matter what your number is. And in this case, the understood exponent would be 1. So you still are going to multiply using the powers of product, or the product of powers property, in the same way. So you have x to the 3 plus 1, which is x to the 4th. Okay? I'm going to leave the rest of those, and you can work through those on your own in that activity on page 464. And we're going to move on to example 1. Okay, so for example 1, if you want to participate by using a sheet of paper, if you take a regular 8.5 by 11 sheet of paper, the example leads you in a folding exercise to demonstrate a product of powers property. So, start with the regular sheet of paper, and you can see that you have one region. Okay, this is one region. You have 0 folds when you have one region. So, if you wanted to fold it in half, lengthwise, fold it down this way, okay, you now have if you open your paper back up, you now have two regions with one fold, okay? So one fold creates 2 regions. Okay, if you fold the opposite direction one time, like so, you've now folded 2 folds. But when you open up, you can see that you have 1, 2, 3, 4 regions. So 2 folds gives you 4 regions. Okay. If I wanted to fold a third time, this is 2. I'm going to fold down this time, so the opposite direction, each time interchanging directions. Okay. So I've now folded 3 folds. And when I open, you can see that I now have 1, 2, 3, 4, 5, 6, 7, 8 regions. So each fold represents the exponent for the power of 2, because you're increasing by a power of 2 each time. So you could then deduce that if you fold it one more time, this one you have 2 regions to the 1 fold. This one you have 2 regions, or excuse me, it'll be 4 regions, but 2 regions to the 2 folds, which is 4 regions. On this one, you have 2 regions each time you fold, and there are 3 folds, so you would raise it to the power of 3. And so using that pattern, you could then say, for 4 folds then, I know it's going to be an exponential increase of 2. So 2 to the power of 4 is going to give me 16 regions if I fold this again. And if you want to go ahead and do that, you can do that, and you'll open it up and you'll see that you do indeed have 16 folds, or 16 regions for 4 folds. Okay? So after n folds then, you would have 2 to the n regions. Okay? And that is using the product of powers property. Now, that only works when you have powers with the same base. In example 2, if you'll follow along with me, on page 466, on example 2, you can see that you are multiplying powers again, but they aren't all of the same base. In this example, they want you to simplify r to the 9th power times s to the 5th power times r to the 7th power times s squared. Okay, so in this case, you know that you can multiply powers of the same base by adding their exponents. So what you want to do is the commutative property of multiplication allows you to move these into any order. So what we want to do is we want to group the powers that have the same base. So r to the 9th times r to the 7th times s to the 5th times s squared. Then you can simplify further by using the product of powers property. So r to the 9 plus 7 times s to the 5 plus 2 would give you r to the 16th power s to the 7th power. And that's going to be as simple as you can get multiplication of powers with different bases. So that's example 2. Okay, example 3. Still on the same page, 466. In this one, we are going to raise a power to another exponent. In this case, they want you to do 5 squared raised to the power of 4. So, 5 squared, as you know, is the same as 5 times 5. So you literally just take your base and you multiply it by itself the number of times that the exponent indicates. In this case, it's no different, it's just that what you're raising to the power of 4 is now a power itself. So in this case, this would be equivalent to 5 squared multiplied by itself 4 times. Okay, so that's what it would look like. Then, of course, each individual 5 squared power could be expanded further by saying 5 times 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 5. So you can then count your numbers of 5s, 1, 2, 3, 4, 5, 6, 7, 8. And to simplify, you would actually have 5 to the power of 8. So what you can see is when you are raising a power to a power, and this is the power of power property that you're going to find on page 466, then you no longer add the exponents, but in this case you can multiply the exponents. So you could say 5 squared raised to the power of 4 is the same as 5 raised to the 2 times 4, or 5 to the 8th, which of course you can see you got when you did expanded notation. Okay? That's the power of power property. Okay, example 4. This you'll find on page 467. They want you to simplify this expression. Okay? So basically they're just taking a bunch of things you've already done and they're putting them all together. Okay? You can figure this out using the properties you've learned, the power of powers property and the product of powers property, or you can do completely expanded notation. I will remind you that m alone is still a power, and it's m to the power of 1. The other thing I'll remind you is that you should always take into consideration the order of operations. So we know that we want to focus on exponents and parentheses before we get to multiplication. So you could take this by saying, I need to first focus on these exponents. So I'm going to raise m to the 4th to the power of 2. So it would look like this. And I'm going to keep the 1 there just to remind us that that is an exponent. Okay, keeping with expanded notation, which, as you can see, takes a whole lot more time. You have m to the 8th there. You could continue, let's see, in this way. And again, you could expand, which would really be awkward and unnecessary. Or you could use the multiplication, the product of powers property, and you could see that 3 times m to the 1 plus 8 is 3m to the 9th. Now, let's look at this without doing expanded property, or the expanded notation, and see that you would do exponents first. Okay, so you could arrive to this same answer by doing it this way. You would say 3m times m to the 4 times 2, because this is the power of powers property, and you would end up with 3m times m to the 8th, and then use the product of powers property to get 3 times m to the 1 plus 8, which is 3m to the 9th. So that would be the same as that, but using the properties that you've learned. And that is lesson 2 in chapter 8. I would like to give you the answers for 8-2A. So if you would like to turn off the video now, and then come back after you've completed the lesson master, I'll have the answers on the board for you.